So guys, we were studying preparation of haloalkanes. One more method of preparation of haloalkanes is Sandmeyars reaction. This is very important reaction, Sandmeyars reaction. In this reaction, we prepare haloalkanes from primary amines. The substrate over here is substrate is primary amine. It's primary amine. Now whenever you have a name reaction, how to make note of a name reaction? First write substrate, then write which reagents are used in that name reaction. Now what is reagent used in this reaction? Reagent is used NaNO2 and HCl. NaNO2 and HCl. We use one more reagent, that is copper bromide or copper chloride. Copper chloride. This is actually Sandmeyars reagent, copper chloride, copper bromide. Now by making notes like this, you cannot forget in which type of reaction what is substrate and what is reagent. Now see how the reaction takes place, how we can get haloarene. Actually we are getting haloarenes from this reaction. How we can get haloarenes, haloalkanes or haloarenes. How we can get haloarenes from this reaction. This is very important reaction. Now see what happens in this reaction. We take primary amine. Amines are the compounds having general formula RNH2. Let us take aniline. Aniline is an amine in which benzene ring is there, and to this benzene ring we have attached NH2 group. This is our R group and this is NH2. This is RNH2. This is called aniline. Its common name is given aniline. This is a trivial name for this. This is called aniline. We treat this aniline with NaNO2 first and HCl. And in the second step, we treat it with copper bromide or copper chloride. Depending upon, if we have to make chlorobenzene, then copper chloride. If we have to make bromobenzene, then copper bromide. We can also get iodobenzenes in this reaction. Now see what will be the product of the reaction. The product of the reaction will be this, for example, chlorine. Now how the reaction takes place, what is the mechanism of the reaction? That's very important. Mechanism of this reaction. Now mechanism of this reaction is very important. Mechanism. It's very important to understand mechanism of this reaction. This reaction, first we take aniline. Let us take aniline. This is our aniline. Now this aniline is treated with, this is hydrogen and this is hydrogen. It is treated with NaNO2 and HCl. In the first step, it is treated with NaNO2 and HCl. NaNO2 and HCl. NaNO2 and HCl. Now let us react first NaNO2 and HCl. This is our NaNO2 and HCl. H positive, Cl negative. Now what happens? If this bond comes back, this bond breaks towards nitrogen atom, we get this O negative attacks this hydrogen atom, we get OH, NOH, and this sodium leaves as sodium positive, it's attacked by chlorine, we get NaCl, and to this there is one N double bond O. This type of compound we get from this NaNO2 and HCl. From NaNO2 and HCl we get OH, N double bond O. This has been obtained from NaNO2 and HCl. Now what happens? What happens in this reaction? See what happens in this reaction. Now see, this is the oxygen atom. It has lone pair of electrons. This oxygen atom can abstract this hydrogen atom. If it abstracts hydrogen atom, negative charge comes over here. We get this type of compound. This is our nitrogen. It has hydrogen attached to it. We have negative charge over here. And this oxygen atom attacks this hydrogen atom, plus we get nitrogen OH, H positive charge, zinc double bond NO. Now see this bond breaks. Why it breaks? Because now oxygen is electron deficient. It becomes a good leaving group. If this bond breaks, then nitrogen gets positive charge. It will be attacked by negatively charged nitrogen. We get this type of species. This type of intermediate. This is hydrogen and this is nitrogen. This is nitrogen and this is our double bond O. Now see what happens in the next step. We have excess of HCl in this reaction, where not only one molecule of HCl, there will be hundreds of molecules, there will be very large number of molecules of HCl present over here. Now see what happens then. This lone pair of electron abstracts H positive from HCl. It abstracts H positive, we get this type of compound. This is our N, this is H, this is N, this is double bond O, this is H, positive charge. Now it is electron deficient to break this bond towards this side and break this bond towards this side. We get, this is our benzene ring, this is nitrogen atom. Now this is double bond, this is N, and this is single bond OH. Now what happens in the next step? Lone pair of electron on nitrogen atom comes over here. This OH leaves with H positive treating with HCl. This OH leaves by treating with H positive Cl negative. It abstracts hydrogen, H positive ion leaves as water molecule. Now water molecule have been lost. What we get over here? N, triple bond N, positive Cl negative. This is called salt. This is called diazonium salt, benzene diazonium salt. Till then, up to now, this reaction is called diazotization. It's called diazotization. Questions are being asked on this diazotization from amine, from the chapter amines, from the chapter functional group containing nitrogen atom. I will study here and we will again study this reaction there. Now see, this is diazonium salt. This is called diazonium salt. Diazonium salt. Any compound in which there is N triple bond, there are two nitrogen atoms, that's a diazonium group. Now see, world's best living group is N2 group. This is the world's best living group. We can last over here N2. If we lose over here N2, this Cl minus attacks this positively charged deficient center, and we get the answer, we get our product. This is our product then. This is chlorobenzene. How we get chlorobenzene from this? First we treat amine with NaNO2 and HCl. The aim of using NaNO2 and HCl is to generate this nitrous acid HNO2, or we can write it OHNO. This is called nitrous acid. Now the attack of nitrous acid takes place on this, and in the final step what happens? N2 leaves, because N2 is the world's best leaving group. It leaves. If N2 leaves, then this carbon becomes positively charged. It is attacked by negatively charged halogen atom and we get the product. Now see, we can use copper bromide, we get bromobenzene. We can use iodide as well, we can get iodobenzene. But the order of reactivity of these iodine, bromine, chlorine is, the order depends upon nucleophilicity. Iodine is more nucleophilic than bromine than chlorine. How can you say that iodine is more nucleophilic? Make acids of these. This is Hi, this is HBr, this is HCl. Now Hi is the strongest acid, this is its weak base. Sometimes weak bases act as strong nucleophiles. This iodine negative acts as a strong nucleophile. Now this is one reaction. This is called Sandmeyars reaction, from which we have prepared what? From which we have prepared haloarenes. From which we have prepared haloarenes. Now one more method of preparation of haloalkanes is, one more method is bromination reaction. Number 4th reaction is bromination. This is very important reaction. Bromination. Bromination of alkenes. Bromination of alkenes. This is very important reaction. In this bromination reaction, what happens? We take an alkene. Let us take an alkene. Now this is our alkene, hydrogen, hydrogen, and we have alkene over here. This is alkene. This is ethene. Now to this ethene, we add bromine, Br2. Now what happens when we add bromine to it? In this reaction, addition of bromine takes place, but it results in the formation of cyclic tribromo-ion intermediate. Now what happens? This pi bond is electron rich. We can break this pi bond towards this bromine atom if we break this bond towards this side. Breaking this bond towards this atom, what happens? This pi bond has attacked over this, or you can see like it like this. You can visualize it like this. Now this is hydrogen, hydrogen. Break this bond. If you break this bond towards this side, we get this carbon negative charge, this carbon positive charge. Then this negative charge attacks on this bromine because I have broken down the bond heterolytically. Now you might think that this bond may break down homolytically, but sometimes it breaks down heterolytically. Under what conditions? Under the influence of electromeric effect. Now see, it is under the influence of the pi bond, under the influence of the attacking reagent, this bond breaks down heterolytically. Now see, we have a lone pair of electrons on bromine atom. If this bond breaks over here, this negative charge, if this negative charge attacks over here, this becomes positive charge. Lone pair of electron attacks over here. Then we get cyclic intermediate. Now this is our cyclic intermediate that is formed. This is very important point. Cyclic intermediate is formed. This is our bromine and this is our bromine. Since lone pair has attacked, therefore positive charge comes over there. Now we have in the reaction mixture Br negative. Now this Br negative attacks. Now the Br negative can attack from two ways. It can attack either from this side or it can attack from this side. Now Br negative ion attacks from that side which has opposite stereochemistry to this Br. For example, if this is our Br, this bond is above the plane, then this Br has to attack below the plane. Break this bond towards this side. This becomes del positive. Br negative attacks over here, but it attacks below the plane. Now this is our Br which was above the plane and this is our Br which is below the plane. Means we are getting anti-product. Anti-product is formed. This is very important. Anti-product is formed in this reaction. The reaction takes place, some important points of this reaction. Reaction takes place through the formation of cyclic tribromo ion intermediate. This is cyclic tribromo ion intermediate. Cyclic bromonium ion intermediate. We write this as, we name this as cyclic bromonium ion intermediate, and the product is anti-product. We get anti-product. It has opposite stereochemistry. One bromine will be above the plane and the other will be below the plane. So question may be asked from this concept. Bromination of alkenes gives syn product, gives anti-product, gives both syn and anti, gives none of these. It gives anti-product. So we can have a question like this. This is our alkene. Now to this alkene we have hydrogen atom attached over here and hydrogen atom attached over here. Now this hydrogen atom is shown above the plane. If the group is already above the plane, then bromine attack will take place first below the plane. Then this attacks, this pi bond attacks first below the plane. We get cyclic tribromo ion intermediate. Now the cyclic tribromo ion intermediate will be like this. This is our hydrogen. This is our Br and this is our Br. This hydrogen, let it has stereochemistry below the plane. Stereochemistry of this hydrogen is below the plane. Now what happens in the next step? In the next step Br negative attacks. Br negative attacks from which side? Now if this hydrogen is above the plane, this bromine has to be below the plane. If this bromine is below the plane, this hydrogen is above the plane, this bromine has to be below the plane. Means this hydrogen is above the plane, the bromine which has already attacked, that has to be below the plane. Now this hydrogen is below the plane, break this bond, this becomes del plus. Now this Br negative attacks. From where this Br negative will attack? Since one bromine is already below the plane, therefore new bromine will attack from above the plane. This will be our product. This will be the product of this reaction. There is one more method of preparation of these haloalkanes, that's Markovnikov's addition. We will discuss that in next lecture because that's a lengthy topic. We will discuss certain questions on this. But remember, bromination is very important. Stereochemistry of bromination is important, and transition state, that is the intermediate which is formed, it is very important. Question may be asked upon the product, what will be the product of the reaction. Question may be asked, what is the transition state involved, what is the intermediate involved, and question may be asked, give the product of the bromination of reactions, give the product of bromination of a given reactant. This is how a question can be asked. Thanks for watching. If you like, please subscribe the channel. and press bell icon for further future notifications. Thank you.